The Harben P-pump is a simple and reliable high-pressure pump to maintain. We'll be showing you in this video how to service, strip and reassemble the pump and how to rectify any faults that may occur. Here we can see the pump's unique radial piston design, which has made it into one of the world's best-selling pumps. The P-pump has a maximum working pressure of 400 bar and a maximum possible flow of 77 litres per minute. It should be noted that if the pump only requires a service, it is not necessary to split the crankcase or remove the barrels. You may not always want to go through the whole video to find the parts you want to see. We've therefore indexed sections of the video such as preparation for service and strip down, valve and diaphragm removal, valve and diaphragm fault find, splitting the crankcase, removal of barrels, removal of center assembly, reassembly of center assembly, replacing barrels, replacing crankcase lid, replacing valves and diaphragms, oil and water bleed, the P-type selector, the Mark II gun, and unit fault find. At the end of the video, there's a short section on how to service and diagnose faults in the P-type selector assembly and the Mark II gun. The pump we're working on is a 6-cylinder 22mm high-lift P-pump. For the purpose of this video, we've carried out all the work on a pump stand. In the field, a pump service can be done on the machine. It would only be necessary to remove the pump if a strip down was required. The first step is to drain the pump oil by removing the drain plug located at the bottom of the pump crankcase. Once the oil has been drained and the drive coupling taken off, the inlet manifold has to be carefully removed. The manifold shown here is the old type rubber inlet manifold. On later models, a different inlet manifold and inlet nut, complete with inlet stem, is fitted. The removal and fitting are almost identical to that shown here. We move next to the front of the pump, where the top hoses are individually removed. Once these top hoses have been undone, the valve nuts are slackened and carefully removed. Here the engineer is starting with the valve nuts on the pump's inlet side before moving to the delivery side. With the valve nuts removed, the delivery valves are gently taken out. They should never be forced, as this will damage the valve assembly. The next step is to use a drift, which is located onto the top of the mandrel from the pump's delivery side. As the drift is being used, the inlet valve, and here we show a high-lift version, is knocked out. The diaphragm and mandrel is then pushed out of the barrel on the inlet side. It is important when removing parts to ensure that they're kept in order to assist in the fault-finding process. With the parts now taken out, a check should be made of their contents for wear and damage. Starting with the high-lift inlet valve, the type of things to look for are to check to see if the spring is broken or if there is pitting and cavitation on the poppet valve and seat. The delivery valve is checked in the same way, looking at the seat, stainless steel ball and the guide. The O-rings on the valve should also be checked. If the pump is fitted with a standard ball type inlet valve like this one, the same checking procedure should be followed. The diaphragms should also be checked. Here we show 3 possible diaphragm failures and their explanations. Pepper pod failure could be due to A, worn or damaged delivery valve, or B, damaged filter element allowing debris to jam the delivery valve. If this failure occurs, you should A, check all delivery valves, B, check all diaphragms, C, replace the oil, D, check water filter. Shear failure is due to excessive running hours. To remedy, check all diaphragms and valves and replace where necessary. Pinhole failure could be due to A, inlet restriction, either through blocked filters or kinked inlet hose, B, worn or damaged inlet valves, C, excessive inlet hose length, or D, the pump having been frozen. If this failure occurs, you should A, clear any restriction on the inlet, B, check inlet valves, C, check diaphragms, and D, replenish the oil. To remove the mandrel from the diaphragm, use the same drift as before and gently ease it out. The mandrel can then be checked for wear and pitting. The inlet and delivery valve nuts should also be checked for damage caused by cavitation. Next, the oil bleed rings are removed from around each barrel assembly. The oil cooler plate is removed next, with its O-ring behind it. This is followed by the removal of the lock nuts on the inlet side. To remove the crankcase lid, the 6 cap screws are taken out. Then 3 8x70mm set screws are placed into the spare holes located between the cap screw holes and are evenly screwed down, ensuring that each set screw is given 1 turn at a time to give even lift of the crankcase lid. Unless done evenly and in this manner, the crankcase lid is liable to split. The crankcase lid can now be removed. To isolate the barrels from the center assembly, the circlip holding the gudgeon pin is removed and the pin taken out. The connecting rod is moved away from the piston, leaving the barrel isolated. It's now a straightforward action to remove the barrel from the crankcase. This process is repeated if all the barrels need to come out. In order to begin removal and dismantling of the center assembly, the 20mm nylock shaft nut must first be taken off. Then the collar and the first counterbalance are taken out. These are followed by the retaining ring and connecting rods. The main bearing. And the second counterbalance. And finally, the shaft key. On the inlet side of the pump, around the base of the shaft, is an oil seal carrier and oil seal, which should be checked and replaced if necessary. With the barrels now out of the pump, an inspection can be carried out, checking threads, oil bleed holes, and barrel O-rings. The piston also needs to be looked over to check for scoring caused by a lack of oil. Once all these checks have been done, the procedure for rebuild can begin. First, replace the shaft key. The pistons are then put back into the barrel inner cylinders. The center assembly is then put back onto the pump shaft in the same order that it was removed. Counterbalance, main bearing, retaining ring, and connecting rods. Second counterbalance. Collar. Spacer. And finally, the nylock shaft nut. It's important that the barrels go back into the same holes, otherwise the oil bleed holes will not be in the correct position. If in any doubt, consult your service manual and the section on barrel coding. All barrels are letter coded. With all the barrels back in position, the individual connecting rods are connected back to each piston with gudgeon pins and new circlips. Never use the old circlips. Before replacing the crankcase lid, the crankcase lid O-ring is checked and placed back into position, ensuring that the join is at the top. And finally greased. The floating bearing in the center of the lid must also be checked. The lid is carefully placed over the barrels and tapped down before the cap screws are replaced and tightened. The lock nuts are replaced on all the barrels and tightened, followed by the oil cooler O-ring and plate. The bleed rings are replaced over the barrels and the bleed nipples screwed down. The delivery valves are greased and placed into the top of their respective barrels and the delivery valve nuts screwed down. The top hoses are the next to be replaced. You must ensure that the air bleed hoses are at the top of the pump, as shown here. At this stage, it's worthwhile checking the safety pressure disc and holder. Pressure discs are color-coded. The disc shown here is colored white, which indicates a working pressure of 280 bar. Refer to your Harben service manual for the correct color coding. We now go back to the inlet side of the pump and the replacement of the diaphragms. They are first liberally oiled and pushed back into the barrels. The mandrel is then eased up into the diaphragm before being gently pushed home using a drift. Once back in position, the inlet valves can then be replaced. And the valve nuts screwed back on. The valve nuts should be tight, but not overdone, as this could damage the valves. Before replacing the inlet manifold, the inlet stems are oiled. The manifold is then replaced, and their collars pushed back into position. The hose clip, where the inlet manifold is connected to the oil cooler, is tightened to complete the manifold replacement. With the drive coupling and bell housing replaced, and the pump back on the machine, the oil should be filled via the plug on top of the crankcase and bled. Here we see how the oil bleeding procedure should be carried out, starting with the bottom barrels and working upwards until all the air is dispelled. The pump should be running in the dump mode whilst it's being bled. The water should then be bled using the air bleed screws on the top two delivery hoses. Once the air has been dispelled, the screws can be done back up to complete the water bleed procedure. The pump is now ready to be run up to pressure. The Harben P-type selector is used on most Harben units operating up to 420 bar to switch between high pressure and dump modes. For the purpose of this video, we will service the selector on a workbench, not on the unit. This cutaway illustrates the internal function of the selector. To get inside the selector, we first undo the fitting connector with its seat and check for wear. The next step is to remove the handle and to unscrew the gland nut. The gland nut is taken out, complete with the shaft, backup ring, O-ring, seal and support. These should be removed from the shaft for inspection. The second selector fitting with its seat is now removed. The seat should always be unscrewed from the fitting and checked. The selector plug is now eased out and checked along with the guides. When replacing the shaft, care must be taken to ensure it's fitted the correct way round, otherwise high pressure and dump modes could be reversed. It's then put back into the selector body, followed by the O-ring and backup ring, and the gland nut tightened down. The selector fittings are now replaced and tightened. Finally, the handle is put back into position over the shaft and tightened down by means of this nylock nut. Before we learn how to service the Mark II gun, we first look at this cutaway, which illustrates how the spindle arrangement inside the body functions. To begin servicing, the gun is first placed in a vise and the guard and trigger are removed. The body nut, shown here, is unscrewed, and the spindle assembly is pushed down and out of the body using a nylon drift. The spindle's individual components are removed and laid out in their correct order for careful inspection. It's important to check all seals, O-rings and seating faces for wear and damage. Reassembly can now begin by first replacing the spindle's components in the correct order: the dump seat, collar, spacer, and the seal support with its energizer and seal. These are now carefully reinserted into the gun body, with the collar and high-pressure seat the last to go in. The nut can now be replaced, making sure not to over-tighten it, as this can cause the trigger mechanism to stick. The guard and trigger are now secured back into position, making sure that the guard does not interfere with the trigger operation. The gun is now ready to be tested. When jetting, the faults most likely to occur are A. Low system pressure. If this happens, checks should be made to the nozzle size, leaks on hoses and connections, and water loss from the selector. B. Pump not running evenly. To rectify this problem, bleed the water and oil, check the inlet filter to see whether it's blocked or damaged, and check the inlet line for restrictions. C. High system pressure. This will cause the pressure disc to burst, and check should be made to the nozzle size, a blockage in the nozzle, the hose bore, and that the gun is not fitted with a choke. For further in-depth fault-finding procedures, refer to the fault-finding section in the Harben service manual. It's recommended that all service work is done in conjunction with the Harben service manual and that only genuine Harben parts are used. If you come across any further difficulties not covered by either the manual or this video, we would recommend you contact your nearest Harben distributor or the main factory for further assistance.